the third planet in the solar system, Earth. Our planet still harbors many unsolved mysteries. To unravel these mysteries, scientists continue to search for evidence hidden within the Earth itself. One of these mysteries in particular has long perplexed scientists. It involves the most serious challenges to life during the planet's 4.6 billion year history. Severe threats to all living things on Earth. Mass extinction. Including the famous extinction of the dinosaurs, the Earth has experienced repeated periods of mass extinction. Among them, the greatest extinction took place 250 million years ago. The Permian geological period was long before the dinosaurs appeared on Earth. Large animals populated the land areas, but 80% of them became extinct.
But it is an extinction that is much bigger than any other extinction in Earth history, including the extinction that killed the dinosaurs 66 million years ago.
Why did the greatest extinction in Earth's history occur? One key to this mystery may be the link between events on Earth and a threat from outer space.
If that happened, that could potentially have caused a cosmic ray winter, which would affect the whole of the biosphere and the whole of life on Earth.
Research has also produced a profile of the prime suspect in Earth's greatest tragedy. The mystery of the Permian extinction. We will track the true culprit behind the largest mass extinction, from deep in the bowels of the Earth to the far reaches of space. Our first destination was the scene of the crime, where the world's greatest tragedy occurred. The Great Karoo, a large plain in southern Africa. Here, paleontologist Roger Smith uses fossils to investigate the mass extinction. This area is a treasure house for fossils from the Permian period, about 300 million to 250 million years ago.
Look at these fantastic footprints. Here's a large animal that walked past here 260 million years ago.
Indentations left on an ancient shoreline are as big as 20 centimeters wide.
Fingers down into the front print, then comes up, down on.
What animals walked here in this way?
Back print up to here, 1, 2, 3.
Gorgonops was about 2 meters in length. It was the dominant hunter of the late Permian period. What was the nature of the Permian period, when such animals made their appearance? The Smithsonian's National Museum of Natural History in the United States has fossil samples from throughout the world. Hans-Dieter Suess describes the Permian as a fascinating period when the ancestors of today's mammals first appeared.
These small animals, these are both so-called dicynodonts, they're distant relatives of mammals. These animals, the little ones, were incredibly common. You can go in South Africa to certain areas where there are rocks with these fossils, and you can find dozens, sometimes hundreds of these animals. We know that they lived in burrows, kind of like rodents, like prairie dogs today or rats. And they would just come live in these burrows. Often they would be preserved in the burrows, perhaps sleeping, and then died because the burrow got flooded.
The next fossils that Suess showed us were of a large animal that appeared in the Permian period. Dense rows of sharp teeth and a big head. What kind of an animal was this? Just try to imagine it. A recreation of Dimetrodon looks like this. The sail on its back is its distinctive feature. It was over 3 meters in length and is thought to have been a carnivore that engaged in hunting.
So the Permian was the first time in Earth history that we have large vertebrate animals on land, backboned animals on land. So these are real pioneers in that we have these large animals. Pariasaurs are early reptiles, so these are the first really large reptiles. And then we have these mammal relatives like this dicynodon here that are also really large. And that's the unique thing, because before, reptiles and mammal precursors were small animals the size of a lizard.
Numerous large animals came onto the scene during the Permian. They appeared to be very strong. So why did they go extinct? Paul Olsen studies the global environment of ancient Earth. He suggests it is necessary to know more about the planet at that time to understand the mysteries of the Permian.
To understand the mass extinction, we have to think about the Earth and the position of the continents. Today, the continents are spread around the globe, separated by oceans.
But during the Permian, the location of the continents was very different.
Many children have noticed that if you take North America and Africa and South America, the coastlines match and they fit together, along with Eurasia, Australia, India, and Antarctica. They all fit together, and 200 million years ago they were fit together in the supercontinent of Pangaea. A giant single landmass with a giant ocean around it. You could walk from Australia all the way to Japan without having to cross an ocean. A completely different world than we have today.
There are now 6 continents on Earth. If we look backwards in time, during the Permian period, when the mass extinction occurred, there was just one supercontinent, Pangaea. What impact did having a single large continent make?
A major difference was in the climate. Today, we have ice at the poles. 200 million years ago, we did not. Carbon dioxide was really high. Because of that, the interior of the continents were really warm. The oceans were much warmer. Because of the lack of ice, there were forests at the poles and a great desert in the drier areas. So the Earth looked very different 200 million years ago than today.
It is believed that surface temperatures on land continued to rise throughout the Permian period. In this environment, living things evolved into larger forms. But very few of them survived into the present.
So during the time of Pangea, the climate was harsh and difficult, but when you did have additional environmental change, it became incredibly important and caused mass extinctions.
What environmental changes took place that caused the mass extinctions? Geologist Yukio Isozaki found a key to unlock this mystery in the Japanese countryside.
でこれはもともとは昔の太平洋の海の真ん中にあったものなんですけれども、プレートが
This was deep under the sea during the Permian, and its traces remain behind in the fossils. The white bands are fossilized shells. It is known that these bivalves grew as much as 70 centimeters in length. The tiny white spots, about 5 millimeters in size, are Fusilina, an ancient type of protozoa. These are single-celled organisms, whose structure can be distinguished with the naked eye. They are marine organisms that have come to represent the Permian period. Professor Isozaki has made extensive surveys at the Takachiho site on the island of Kyushu in western Japan. He found strata that predate the mass extinction.
で縦に縞模様が見えてますが、これが地層が溜まった面です。向かって左側の方がペルム紀の中期っていって少し古い時代、こちら側がペルム紀の後期で新しい時代になります。でここに実は絶滅を研究する意味ですごく大事な境界があります。
These strata accumulated at the bottom of the sea and contain a record of roughly 8 million years leading up to the mass extinction. By analyzing the fossils in chronological order, it was discovered that beyond this line, there was a sharp decrease in Fusilina and other organisms that lived in the warm sea.
古生代の終わりに起きたこの史上最大規模の絶滅の原因が、絶滅の規模が非常に大きいということが分かっているんですけれども、原因がよく分かっていなかったんですね。しかしそれは1回だけではなくて2回起きたんですね。長い地球の歴史から見ると非常に短期間に2つ続けて起きたと。
So, the largest mass extinction in history took place in 2 stages? Professor Isozaki took samples of rock in chronological order from 200 spots. A detailed analysis followed. The Permian rock samples collected in Japan crossed the Pacific Ocean to the west coast of the United States. Joe Kirschvink at Caltech is a research colleague of Tokyo's Isozaki. He used specialized equipment to analyze the Takachiho rocks.
These are the rocks that I collected with Yukio Isozaki from Kyushu. They're very nice, well-bedded Permian limestone. And we drilled out small holes and cores that we can run on the magnetometer system in the other room.
This is a magnetometer. Professor Kirschvink built it himself from scratch. The magnetometer can detect the orientation of the Earth's magnetic field, recorded on these rocks over 200 million years ago.
When a rock forms, there are tiny bacteria that make little magnetic recording particles, magnetite crystals. These particles are almost the same as you find on typical credit cards or ID cards. So it makes the rock extremely stable and a good recorder of the magnetic field when the rock formed.
What do the magnetic fields recorded in the rocks tell us?
So, if we want to understand where the Earth's magnetic field comes from, we can use a melon as an example.
To illustrate his point, the professor turned to a melon.
Okay. So as we slice through the Earth, we see that there's a crust and a mantle, but inside there is a large hollow sphere that's actually filled with liquid iron.
Comparing the melon to the inside of the Earth, there's actually a close resemblance. The skin of the melon is the Earth's crust. The meat of the fruit is the mantle. The inside, where the seeds were, represents the core.
The actual liquid outer core is where the magnetic field forms. And so I can represent that with some syrup. I'll just pour it in around the edge.
Syrup on a melon? Looks like Professor Kirschvink has a sweet tooth.
Structure of the Earth looks like. The actual magnetic field is formed in the center of the Earth in the liquid metal outer part. It's actual convection where the fluid moves, and that generates the magnetic field. It's actually oishi.
Deep inside the Earth, beyond the 2,900-kilometer thick mantle, the outer core is comprised of liquid metal, melted into a sticky mass just like syrup. The hot, convective liquid metal. Add to this the force created by the Earth's rotation. The flow of the convection forms a vortex. This vortex creates magnetic energy, much like an electrical coil. From this activity in the core, the Earth is enveloped in a magnetic field called geomagnetism. Geomagnetism is what makes a compass point north. Geomagnetism also acts as a shield to protect life on Earth from the dangers of solar wind and cosmic rays. The Permian rocks that Professor Isozaki found in Japan. Professor Kirschvink's measurements revealed some surprising results. In the early Permian, when Dimetrodon first appeared, the Earth's magnetic field was the reverse of what it is today. A compass would have pointed south. It is not uncommon for the Earth's magnetism to reverse, but in the early Permian period, it was stable for 10 million years. However, entering the late Permian, the magnetometer results revealed that the magnetic field suddenly began to reverse repeatedly.
The most interesting thing about this study is the change in the behavior of the magnetic field. It went from a very static time with no reversals to suddenly becoming active reversals every 250,000 years again, and so forth. And the answer to that question, what happened, has to be down in the core, probably at the core mantle boundary.
The unusual frequency of reversals, measured by Professor Kirschvink. What caused them? Hearing these results, Professor Isozaki speculated on the causes.
これでいよいよ地球の表面で起きた生命の大量絶滅と固体地球の中で起きた大きな出来事、これは実は超大陸ということが関係しているんですが、そういうものとか結びついて議論できるなというふうに確信をしました。
So, behind the mass extinction was the supercontinent? How did the supercontinent Pangaea, which formed some 260 million years ago, contribute to the extinction of life? Isozaki's attention was drawn to the Earth's mantle. For a supercontinent to form, enormous plates need to submerge. This leads to the accumulation of masses of material from the plate, called giant megaliths. The giant megalith falls. This disrupts the convection flow in the core. It is believed that this was linked to the changes that repeatedly reversed the Earth's magnetic field.
超大陸ができるということと地球内部の核に大きな影響を与えるということはほとんど一緒だろうと。でこのことが実は地球表面で起きた大量絶滅にも影響を与えているのではないかと考えられるからです。
The supercontinent caused geomagnetic instability. How was this connected to the mass extinction? The search for the true culprit headed next to the European Organization for Nuclear Research, where cutting-edge research takes place. Jasper Kirkby points to the possibility that the reversal of the magnetic field exposed the Earth to threats from outer space.
Because when the geomagnetic field changes, essentially the only change in the Earth's environment is that the cosmic rays increase.
Dr. Kirkby has created a device that simulates the space between the supernova and our solar system. A supernova is an enormous explosion that occurs when a large star reaches the end of its life. These explosions release galactic cosmic rays that travel all the way to the distant Earth. Think of this silver research device as the Earth. Here we can study the impact of cosmic rays created by an accelerator on the device representing Earth. The device is filled with gases like nitrogen and ammonia, so the conditions are the same as those in the Earth's atmosphere. Dr. Kirkby's experiments have shown that surprising effects are seen on the atmosphere when cosmic rays enter.
Millions of light years away, supernovae are exploding, stars are exploding with huge energies. What we have found is that ions produced by cosmic rays in the atmosphere are very, very important for the formation of certain particles which grow to become the seeds for clouds.
Cloud seeds are created when cosmic rays pour into the Earth's atmosphere. When these attract the water vapor in the atmosphere, immense banks of clouds are born.
Those cosmic rays are creating ions in the atmosphere affecting the formation of cloud seeds on Earth, affecting the formation of clouds, affecting our climate.
Surprisingly, it is believed that an increase in cosmic rays might raise the likelihood of cooling on Earth. Professor Isozaki believes that the late Permian magnetic reversals were the beginning of a cold era on Earth.
少なくとも第1回目のことに関しては熱帯域に住んでいた生物が大量に死んだということが分かってきたので、寒冷化が非常に大きな原因であったということが明らかになりました。その寒冷化が起きたのとほぼ同じタイミングで地磁気に大きな変化が起きたということをカーシュビンクさんが明らかにしてくれた。この2つが関連していないはずはないだろうというふうに確信をしました。
Let's review what occurred during the first stage of the late Permian mass extinction. This was the age of the supercontinent Pangaea. Massive plates submerged when the supercontinent formed, which caused megaliths to fall into and disrupt the core. A series of reversals of the Earth's magnetism resulted. The magnetic reversals weakened the Earth's geomagnetism. As a result, large barrages of cosmic rays hit the Earth. Isozaki believes that this led to the formation of clouds, as Kirkby demonstrated. The later Permian period, the sun is obstructed and temperatures fall. The cooling trend caused by the supercontinent begins. Some 60% of the species that had thrived in the temperate environment were unable to survive. However, the largest mass extinction in history was not over yet. Further changes taking place on Earth threatened even more devastation. Scientists now believe that the mass extinction that occurred at the end of the Permian period took place in two stages. The supercontinent Pangaea seems to have played a key role in each of the two distinctly different stages. In the first stage, it disrupted the Earth's geomagnetism, leading to a rain of cosmic rays and dramatic climate change. Planet cooling killed 60% of the species, but many of the surviving species would be wiped out in a second wave of catastrophe, again caused by Pangaea. What happened during the second stage of the mass extinction? Our search to understand the causes of this global transformation took us back to Africa. In northern Ethiopia, Mekele is a city at 2,000 meters above the sea. Leaving the high ground of the city, we head downhill rapidly. This is the site of an enormous landform carved into the African continent, the Great Rift Valley. The valley is so large, it can be seen from space. This cleavage in the Earth is 7,000 kilometers in length. The rift was made by the same plate activity that created the supercontinent Pangaea. It is the front line of forces that, someday, will split the continent in two. Some scientists believe the Great Rift Valley holds a key to the mystery of the second mass extinction. We were guided through the valley by the Ethiopian seismologist Atale Ayale.
So, this place is, the way we see it now, looks stable, but it is moving to form the future ocean. So, as we speak, it's very surprising that it is slowly moving and separating, which humans don't see it, but it is happening now as we speak.
The Great Rift Valley fated to split the continent and sink into the sea. But that is millions of years off in the future. Descending 2,000 meters, we head down to sea level at the base of the Great Valley.
This is a marina and a campsite area. Now a marina.
Here in the Great Rift Valley, we'll unravel the mystery of the mass extinction. The next morning, Professor Ayale leads us toward a volcano in the Great Valley. The land is covered with unusual rocks containing large amounts of salt. Beyond the next ridge, a starkly strange vista unfolds before us. The Dalol volcano is the lowest volcano on the surface of the Earth. It is more than 40 meters under sea level.
And this very attractive color comes from the interaction of the heat source with groundwater and salt, potash, and sulfur. So throughout the year it's just like this, and it's really we can call it one of the wonders of nature here.
Highly acidic hot springs bubble up from the geysers.
This volcano is so unique because it is a manifestation, surface manifestation of the mantle plume. The plume is a huge, massive heat source beneath the surface of the Earth.
What on earth is a plume? This image depicts temperature differentials inside the Earth's mantle, as measured along the Great Rift Valley. The red areas where temperatures are highest represent the plume. The Dalol volcano developed in the area where the plume is closest to the Earth's crust. Dalol is called a wonder of nature. Because of the Great Rift Valley, we can see the effect of the plume with our own eyes. Scientists consider a plume like this to be an important suspect in the mass extinction that occurred at the end of the Permian period. Takachiho in Japan, where rock strata from the ancient Permian period were found. Yukio Isozaki's home turf.
この白い方がペルム紀最後の部分です。でこの黒い方が三畳紀の一番最初で、ここが大量絶滅のタイミングを表しています。
The second stage of the extinction events. Professor Isozaki believes that a plume caused massive eruptions during this phase.
地球の内部から上の方に向かって大きな上昇流が生じる。これを我々はプルームと呼びますが、超大陸に関係してできたプルームは非常に規模が大きかったので、特に我々はスーパープルームと呼んでいます。
The supercontinent Pangaea. Once again, it was causing an event inside the Earth that would lead to mass extinction. What happened this time? The impetus came from those giant megaliths that fell into the Earth's core. This caused great changes within the mantle. A plume formed underneath the supercontinent. It was far greater in scope than the plume that created the Great Rift Valley. This superplume became a planet-changing force. The superplume pressed toward the surface of the Earth. Part of that tremendous energy took the form of magma that erupted. The eruptions sometimes reached as high as 2,000 meters. It is believed that these giant eruptions continued for an astounding 1 million years.
このスーパープルームは地球表面の環境、そしてそこに住んでいる生物に大変大きな影響を与えたということは間違いがないと思います。超大陸ができた結果、地球内部に大きな変化が生じて、見たことがないような規模の大きな大量絶滅が起きたというふうに考えられます。
The eruption spewed massive amounts of CO2 and methane, causing a rapid warming and drying of the planet. The two stages of planet transformation resulted in the extinction of 80% of the species on Earth. The era known as the Paleozoic had come to an end. During the Triassic period, which followed the Permian, the supercontinent Pangaea continued to influence life on the planet. During the Permian, Pangaea caused changes to Earth's geomagnetism. As a result, the planet experienced severe cooling. Next came the phenomenon of a superplume inside the mantle, which caused extensive volcanic activity and global warming. The supercontinent Pangaea was the true culprit of the mass extinction. 50 million years later, in the Triassic period, it would again threaten life on Earth. Professor Paul Olsen studies this later planet event related to the supercontinent Pangaea. The crime scene, outside of New York City. A stratum of rock found there, dated to the Triassic period. After the Permian mass extinction, the Triassic had seen a revival in the number of species of life. But then, here we find a large amount of a rock called basalt. The presence of basalt indicates that this period was one of active volcanic eruption. The stratum below the basalt records the tragedy that befell life forms of the Triassic period.
On the layer underneath this lava flow, there are thousands of dinosaur footprints. These are animals that were roaming about on the floodplains and the shores of lakes just before the lava rolled over the landscape.
Lava attacked the small dinosaurs that had just begun to appear during the Triassic period. What had taken place? The scale of the volcanic eruptions drew attention. Based on an analysis of the accumulated basalt, it is estimated that the volcanic activity during this period continued for hundreds of thousands of years. A further detailed analysis of the stratum revealed a dramatic increase in CO2 gases and the extreme warming of the climate on a global scale. The lava that gushed from the volcanoes covered an area of 10 million square kilometers. This is the equivalent of 1/3 of the surface of the moon. The lava field is called the Central Atlantic Magmatic Province, or CAMP. This colossal magma flow was caused by the separation of the supercontinent Pangaea, which was in its early stages. The chasm that resulted is the area that separates North America from Africa. This was also when the Atlantic Ocean was born. The Hudson River, which flows on the west side of Manhattan, is the site of that very rift. This sheer cliff is formed of lava from the humongous camp eruptions.
We had the splitting of Pangaea, the eruption of the lava, massive changes in climate. Many organisms were unable to cope. Most of the primitive relatives of dinosaurs went extinct and left dinosaurs to take over the planet. And that really brings in the beginning of the real age of dinosaurs.
With the demise of the supercontinent Pangaea, a new age emerged. As the continents drifted, the throne of the animal kingdom passed to different actors. The continents on Earth actively continue their movement. What does the future hold?
The continents have split apart and moved to their present configuration. But the continents will keep on moving in the future. And maybe 250 million years from now, different continents will collide again and produce a new supercontinent of Pangaea. It may change in ways that we cannot possibly imagine.
We face the frightening prospect of another supercontinent. If it comes to that, what will be the fate of humankind?
地球の変化が非常に大きな局面を迎える時、例えば超大陸ができたり分裂をしたり、そういう時に表層環境を大きく作り変えられ、そして我々生物は大きな影響を受けると、そういう意味で、我々の運命の重要な部分を地球の変化が握っているということが言えると思います。
The movement of the continents may determine our fate. To explore our future, we visited Oman on the Arabian Peninsula. Since trade flourished here around the 15th century, people would say you can find anything in Oman.
كل ما الحجر كريمة جاي مع عمان كل بالبلاد تعرفوا عنه ستوتت العمان.
In Oman, you can see something that we usually cannot lay our eyes on: the Earth's mantle. This is called a sheeted dike complex. About 100 million years ago, this area was under the sea, where ocean floor volcanoes were vigorously active. 100 million years ago, a border in the plate formed in the area where the volcanoes were erupting. As the plate drifted, carrying rock from the mantle, it moved toward the Arabian Peninsula and climbed up on the land. The world's geologists are drawn to Oman, where the rocks of the ancient mantle can be seen and touched. Katsuyoshi Michibayashi has been studying the geology of this area. His research aims to explicate phenomena deep inside the Earth, like the plate activity that created the supercontinent. Here he works with an international project that is drilling into mantle that is normally deep under the Earth's crust. Changes in the crust caused the 100-million-year-old mantle to come to the surface. Previous drilling produced a distinctive green rock called peridotite. It is one of the rocks that comprise the mantle.
So welcome to Oman Drilling Project Site CM2B in beautiful Wadi Zeeb in the Samail Mountains. Oman Drilling Project is an international research project involving 150 scientists from almost more than 20 countries. It's a really unique opportunity to be involved in this scientific drilling.
The project will drill to a depth of 400 meters. The plan is to extract rock from the very intersection of the mantle and the crust, from 100 million years ago. Today, the drills reached 66 meters. The sample from that stratum was black rock. It is a type of peridotite called dunite. It forms when magma passes through the mantle.
やっぱりこうやって手に取ると、やっぱりまるでマントルがね、マントルを手中に収めたようなそういう気分になるわけですよ。それはね、やっぱり最高の気分ですね。楽しい。だから結構ね、マントルっていうとドロドロでね、溶けてるっていうふうに思われがちなんですけども、実際にはこういう岩石でできてるんですね。このぐらいのねスケールで見ると本当に硬くてほとんど動かない岩石なんですね。
The mantle is a mass of hard rock. How is it able to move the enormous continents? The drilling project will mine a total of 800 meters of sample cores. The multi-year project will reveal the actual nature of the mantle, which continues to move. The planet Earth harbors wild things in its bosom. The repeated occurrence of mass extinction. After each event, new beings took center stage in the evolution of life forms. And then, we mammals became the lead actors on the face of the Earth. In its present form, divided into 6 continents, the Earth has given life a tranquil environment in which to flourish. But is this merely a temporary lull? The Oman drilling project continues to reveal the secrets of the depths of the Earth.
待ってたよこれ。いやこれ本当に欲しかったんやね。ちょっとわかる？もうねマントルクラスマントルクラスマントルクラスマントルクラスマントルクラスだからね。イエーイ。やっぱり生で見るのが重要で、生で見たやつを見えないね地球内部に想像してみることによって本当の意味の地球が見えてくるかなと思うんだよね。これ光ちょうどいいよ。最高ね。やばいこれ。